All right, you guys, we are on to topic number 2. So this was where we learned to solve quadratics, meaning finding their x-intercepts by graphing and factoring. So clearly the graphing part is super simple because we're literally just going to be putting this in Desmos and copying the graph down and figuring out where it crosses the x-axis. All right, so I'm going to take our first little function here, x squared minus 8x plus 12. I am going to go into Desmos and type that in. So y equals x squared minus 8x plus 12. All right, and I'm going to make note of all of these key points. Plus, they want me to fill in a table, so that is something I could definitely do. So let's see. Sorry, I'm writing down all these points because I'm not going to remember them. Now, I do want a fifth point, and I know I can't really write or point on this. I need a fifth point. So the fifth point I'm going to use is going to be the reflection buddy of the y-intercept, right? So my y-intercept is 0, 12, and I know that's a perfect point. So he's going to have a perfect point little reflection buddy on the other side of the parabola. And if I count that, it looks like that is 8, 12. So I'm going to use 8, 12 as my fifth point. You, of course, can use any of the other points that you can identify are perfectly on there. Remember, you can go to your little gear and drop a table, and it will tell you, right, if I just, oops, sorry, did not mean to do that. You can type in any value you want. You can't scroll up or down on this table, but you can type in, like if I type in 8, it's going to tell me it's 12. Right? If I type in 7, right, it's going to tell me it's 5. And notice as I'm typing these things in, it's plotting those points on the graph, right? If I type in 8, okay, so as I type in numbers in the table, it's going to find the corresponding y value for me, okay? All right, so I'm going to go back here. Okay. Sorry. So let's see. I'm just going to start with the 0, 12 because it's the y-intercept. And then I'm going to have my 2, 0, and my 4, negative 4, 6, 0, and 8, 12. So I'm just going by evens. Again, I really don't care what 5 points you put in your table. Just go pluck 5 points off the table in Desmos and you're all good. All right, I'm going to plot these now. Now, 0, 12 is clearly off my graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He only goes to 10. If you just want to go off the graph a little bit to 12, that's great. Then let's see, 2, 0, 4, negative 4, 6, 0, and then 8, 12 is going to be up here. But again, there are other points in between, right? So if you want to use the 1, 7 or whatever that point was, then that's fine. Really, all we care about is the solutions, but it does ask me to graph, so I'm going to do that really quick. Let me scooch this little guy up. All right, that did much better. All right, I'm going to put little arrows on the ends of my graph there. Okay, so I know it's a lot of work when actually all I needed was the solutions, which are these guys right here. Right, but if it asks you to make a graph on your test, it's going to be worth points, right? So that's not something we just want to breeze through. So clearly our zeros are 2, 0, and 6, 0, which of course I also get from the table right here, yes? All right. So there's so many different places I can go find those solutions. All right, let's do one more of those, then we're going to move on. All right, so I'm going to go to Desmos and type this in. Here we go. I'm going to clear out this guy. So y equals negative 2x squared minus 4x minus 4. I'm going to kind of move my graph a little bit. All right, so obviously I'm hoping the first thing you guys notice is that this guy is opening down and does not come up high enough to ever reach the x-axis, right? So right away, I'm just going to go ahead and fill in. What are the roots? There are none, right? So this is no real solutions. Okay, it does have solutions, but we've talked about this. They're imaginary, and that's something you'll learn in Algebra 2. I do still need to create the graph, so I'm going to go back here. Sorry, I'm going to go look at my table for this guy. So let's see, -2, -4, and then we have our vertex at -1, -2, and then we have 0, -4. I'm gonna type in -3. Oh yeah, that gives me a nice number. So -3, -10, and then let's do, and 1 is -10. So again, I'm just finding 5 points that I can graph on my graph, because your graphs have to be exact. Please don't just be like, oh, just drawing some, like, it's about like that, right? You have to be very specific. I'm gonna be checking for exact points here. So -2, -4, -1, -2. All right, so I'm just -3, -10, and then 1, -10. Right, so this is going to be our parabola. Good enough. There we go. And I'm going to go put those points. I like to always do my X's from least to greatest. Again, if yours are scattered, it's not going to bother me. So my X's went from -3, because we always read graphs from left to right. So -3 to 1, and then I'm going to plug in those values, right? So we went from -10 to -4 to -2, back to -4, and then back to -10, right? Which just kind of reinforces that whole symmetric property if you write them from left to right. All right, here we go. What is a solution set? Okay, so just to remind you some vocabulary, right? Remember, solution sets are when they put the solutions in curly brackets instead of writing them as ordered pairs. Okay, so it says, what does the solution set for f of x equals 0 appear to be? Please make sure you don't get confused by the f of x equals 0, right? We know to solve a function, it has to be set equal to 0, right? So that's really all they're saying right there is this function, whatever it is, has been set equal to 0 and graphed, right? So that tells us that this point right here, right, and this point right here are the solutions of the function, right? And if I'm looking at my graph, I would think that those were about 7.5 and 17.5, so I'm picking C. Okay. Obviously, A doesn't make any sense because there's only one solution, and clearly there's two. D doesn't make any sense because a quadratic cannot possibly have 3 solutions, right? And so that really narrows you down to just B and C, right? And that's just a matter of paying attention to your variables, okay? All right, let's move on to our last 4 questions, which are solving by factoring. So remember, when you solve by factoring, you are going to factor it. And once you factor it, then each factor gets set equal to 0. And then that's how you solve for x. I'm just going to draw a little template here, a little review, right? So we factor it, we find the 2 factors that multiply to give us the quadratic that you're given. Then we set the factors equal to 0 and find x that way. Please be aware on your test, I will be checking for every single step of this process. So if this is a 5-step process, before you get to your answers, then every single one of these steps is going to be worth a point. So if all you give me is the solutions and you don't prove it through factoring, you're missing 80% of the points for that problem. Okay, so please, some of y'all are like, oh, I'll just use Desmos to find the solutions. But that's not the point, right? The point is to solve by factoring. And if you can't show me that you can do that, well, then I can't give you credit for the problem. Okay, so just be aware. All right, so here we go. Let's review factoring. So we're going to do our number puzzle because he's a quadratic trinomial. And remember, we multiply the A times the C. Okay, so we're going to multiply 5 times -70. Oh, you know what I'm going to do first? Did you guys happen to notice that there was a 5 GCF in there? If you don't, it's okay. But I am going to go ahead and divide everybody by 5 because it's going to make my life so much easier to take out the 5 and get all my numbers to be a lot smaller than they are currently, right? It's just going to be easier for me. So that's going to give us x squared plus 5x minus 14. Now, technically, 5 is a GCF, but he does not contribute to the solution pool. So I really actually don't care about him anymore, which I'll talk more about when we get to the very end. Okay. okay? But now this is a much easier problem, right? Look how much smaller those numbers are. Now I'm multiplying 1 times negative 14, so I'm looking for the factors of negative 14 that add to give you 5. And it looks like those are going to be 7 and negative 2. Now, if you don't notice the GCF, that is totally okay. We're all going to get the same answer at the end regardless, okay? All right, so now remember when we find those two magical numbers, that tells us how we got that positive 5x in the first place. So we got it with a positive 7x and a negative 2x. And then I'm going to bring down my little outside guys. And voila, we've turned it back into his original 4 term. And then we're going to split it down the middle. And we take the GCF of each side. So let's see, on the left side, x squared plus 7x. It looks like they have an x in common. And then in parentheses, right, this is what you want to think about. What if I divide the x out of each term, right, what is left? So I'll have 1x left in the first term, and I'll have a plus 7 left in the second term. Then we go over here to the right-hand side, negative 2x minus 14. Right? So they have a negative 2 in common, and you do have to take out the negative 2, right? Whatever that sign is, it has to come out. So we are going to divide each of these guys by negative 2 so that we can figure out what is left. And hopefully you can see that that's going to be x plus 7 because the double negative there. And I'm going to put my little smiley face because my parentheses are identical, which has to happen. If your parentheses right here are not the same, then that tells you that you've done something wrong up to this point, right? So then I'm going to take out the x plus 7 because now that's the GCF because both of these terms have an x plus 7 in common. And then if I divide out the x plus 7, then I'm left with x minus 2, right? Our little outside pieces here. And those are our two factors. But we're not finished because we're not just factoring, we're solving, right? So when we solve, we need to take each factor and set it equal to 0. All right, so I'm going to take x plus, actually, I'm going to do that over here. So I'm going to take x plus 7 and set him equal to 0. And then I'm going to take x minus 2 and I'm going to set him equal to 0. Sorry, I'm going to scooch these over. Okay. Sorry about that. There we go. And then these are just easy little baby one-step equations to solve, right? If I want to solve for x, on here I'm just going to subtract the 7 to the other side. All right, so that's going to give us x equals negative 7. And I would add the 2 over here to solve for x, which is going to give us x equals 2. Now, if some of you guys are wondering, well, Miss Jester, what happened to this 5? Well, technically, the 5 would come down right here to be in front as a factor. But if I set 5 equal to 0, well, that doesn't even have an x attached to it. It's not even true. Is 5 equal to 0? No, right? So that's why the GCF at the beginning is not really important in the solving process. It is important for factoring, but it's not important for solving. Okay. Now, if I were you and I was taking a test that was 60% of my grade in the last 2 weeks of school, then I would totally check my answer in Desmos and make sure that my solutions are, in fact, negative 7 and positive 2. So, I'm going to go to Desmos and I'm going to type in that quadratic function that I started with, 5x squared plus 25x minus 70. Now this graph is going to be huge because the y-intercept is negative 70, right? So I'm going to finagle that and move it around. And looky there, positive 2, negative 7. Okay. But again, if you do not have all of this work right here, if you don't have all of this work to support your answer and you can prove to me that you know how to solve by factoring, then I'm not going to give you any points for this question, right? I don't really actually care about the answer. I know I can get the answer from Desmos. What I care about is the factoring process, okay? So make sure you can do it. All right, number 11. I've got another lovely quadratic here. Notice it says n. That's okay. If you want to change those to x's, that's okay too. My only issue is not set equal to 0. So step number 1 is our equations have to be set equal to 0. All right, so we're going to get n squared minus 7n, and we, of course, want that minus 8 constant, right? Make sure you put the term in the right spot, right? He's a constant, so we want him at the end. He's our c value. And then we're going to factor from here. And this is a pretty easy one to factor, right? I'm going to multiply my a times my c, so 1 times negative 8, which means negative 8 goes on the top of my number puzzle, and that b term, negative 7, goes in the bottom of the puzzle. So we're looking for the only two numbers in the universe that multiply to give us negative 8, but add to give us negative 7. And I believe that is going to give us negative 8 and 1. All right, and so that tells me that we got this negative 7n from a negative 8n plus 1n. And I'm writing the 1 just because. And then I bring down my outside terms, and it's the same process, exactly what we just did above, right? These are the same steps over and over and over again, and we've done them a bajillion times. So just a matter of refreshing our memory here because it's been a couple of weeks. All right, so here we go. N squared minus 8n. Looks like those guys have an n in common. And if I divide out the n, again, if you need to write that underneath, please do. If I divide by n, that's going to leave me with 1n and then minus 8. And then on my other side, the only thing that 1n and 8 have in common is a 1. And yes, I'm going to write plus 1. So now I'm dividing everybody by positive 1, which is still, of course, going to give me n minus 8, which, happy face, that's exactly what I was supposed to get because our parentheses have to be identical. So now the n minus 8 is the GCF, so we're going to take the n minus 8 out, and then the leftovers on the outside are n plus 1. Now those are our factors, but not our solutions, right? So next step, to finish this off, we need to take each factor and set it equal to 0. I'm just going to keep drawing those little tracks so I don't lose anybody. So we're going to get n minus 8 equals 0 and n plus 1 equals 0. So we're going to add the 8 to the other side, which gives us positive 8. And then we're going to subtract the 1, which gives us negative 1. You know what I'm doing next, right? I'm going to Desmos, excuse me, and I'm typing in the function. Now, Desmos only takes x's, so I'm going to change it to x squared minus 7x, and then of course, I'm sorry, I forgot my 7. There we go. And then, of course, the minus 8, because it has to be set equal to 0 to put it in Desmos also. So let me go back to my home screen here. There we go. So there's my graph, and what do you know? Negative 1 and 8 are the solutions, and I got them through factoring. Awesome. Okay, moving along. We got 2 more left. Let's move up here. All right, so number 12. We obviously are not set equal to 0, so you either need to do one of two things. You need to move the p squared over here, or you need to move these two terms over to join the p squared term. Now, me personally, when I factor, I never want my p squared or my x squared term to be negative ever. So I am totally going to be bringing these two terms over to join the 3p squared. So that's going to give me 3p squared minus 14p minus 80, right? Because terms have to change sign when you move to the other side. We're subtracting them over. I don't see a GCF because 3 doesn't go into 14 or 80, so that means I'm just going to factor as is. So I've got some pretty big numbers, but that's okay. So again, we're going to multiply the a times the c, so 3 times negative 80 is negative 240, and our middle term is negative 14. So we want the only two numbers in the world that multiply to give us negative 240, but add to give us negative 14. All right, well, if you don't know what those factors are, remember you can go to your calculator and you can go to your y equals and type in negative 240 divided by x, and then negative 240 divided by x plus x. And then go look at your table, and then go until you find negative 14 in your table. And I have done this, and my calculator is telling me that it is 10 and negative 24. All right, so that means that this negative 14p was created from a positive 10p minus 24p. And then I'm bringing down my outside, guys. If you want to, you can switch the 24 and the 10, right, as long as you keep their appropriate signs, right? That'd probably actually be easier in this case, but that's okay. All right, so I am going to split it down the middle. And the way that I've written mine, it looks like my left side, these two terms, it looks like mine only have a p in common. So if I divide the p, 1p out of each of these terms, that should leave me with 3p plus 10. Okay. All right, now I need to go to the other side, and I need to find the GCF between negative 24p and negative 80. Now, if you don't know that off the top of your head, use your context clues, right? We totally know that this parenthesis has to be 3p plus 10. So you can ask yourself, well, what am I dividing by to get a 10 and a 3 here? And you'd be like, oh, I divided by negative 8. I knew it had to be negative anyway because this sign has to come down no matter what, right? And so I know it had to be negative 8 because that's the only way I'm going to get a 3 and a 10 inside the parentheses, right? So we can use that to our advantage, right? So I'm dividing by negative 8. If you accidentally just divide by negative 2 or negative 4, then your parentheses are not going to be the same, and you'd be like, oh, there's a bigger GCF, right? So that wouldn't be that big of a deal. All right, I'm going to put my little smiley face because my parentheses are the same. All right, so now I have 3p plus 10s in common, so I'm going to take that out as the GCF, and then p minus 8 becomes our second factor. And then, of course, we're done factoring, but we're not done solving. Sorry, I know I'm like a broken record, right? And so I'm going to take each factor and set it equal to that 0. So 3p plus 10 equals 0, and p minus 8 equals 0. Now, obviously, the second equation is super easy, right? Because we're just adding the 8 to the other side. So that's just going to give us p equals 8. Okay, but over here on this first one, we've got a two-stepper, right? So we've got to subtract the 10. So we're going to get 3p equals negative 10, and then we'll have to divide by 3 to get that 3 multiplier off the p. So I'm getting p equals negative 10 thirds. I barely fit that on there. Yikes. Okay. Let me see if I can, hold on. See if I can grab all of this and just scooch it up a notch. There you go. Okay. All right, you know what's coming next, right? I'm totally going to go to Desmos, and I'm going to check my answer. Because again, this test is worth a lot of points, right? And so I'm going to type in 3x squared minus 14x minus 80, and I'm going to go look at those solutions. And I totally did not put 80. There we go. That's better. I was about to freak out for a second. All right. So again, yay. Look at, there's our positive 8, 0, right? And then we've got negative 3.3 repeating, which is, if I type in my other solution of negative 10 thirds, there we go, you'll see that it is negative 3.3 repeating, right? So remember, Desmos is always going to give it to you as a decimal, but when you solve by factoring, you're going to get everything as an improper fraction, right? And I want you to leave it as a fraction, of course, right? So just double check to make sure that your fraction is equivalent to Desmos's decimal, okay? All right, number 13. 30a squared minus 6a minus 36. All right, well, I don't know about you, but those are a bunch of big numbers, and I happen to notice that they all have a 6 in common. So much like number 10 over there that had the 5 in common, I'm going to go ahead and divide out the 6. Again, you don't have to do this. If this confuses you, it is not a step you need to do. You're just going to have really big numbers, but we'll all get the same answer at the end because everything's going to reduce down to the same exact thing. All right, so I'm going to reduce everybody by 6, which is going to give me 5a squared minus 1a minus 6. All right, so much smaller numbers, so a lot easier to handle. So I'm looking for the only two numbers that multiply to give us negative 30, but add to give us negative 1. And I'm pretty sure that's going to be a 6 and a 5, and it looks like the 6 is the one that needs to be the negative, since we have to get a negative 1 when we add, right? All right, so I'm going to go ahead and split my a value. Now, do you guys happen to notice that the 5 is in the front and the 6 is in the back? So if it's cool with you guys, I'm going to write the plus 5a in the front and the minus 6a in the back, just to make my life a little easier when I'm finding my GCFs here in a second. It doesn't matter, again, what order you put those two terms in, as long as their signs are correct. The order doesn't matter. We'll all get the same answer. All right, so it looks like on the left we have a 5a in common. So if I divide a 5a out of each term, that is going to give me a plus 1, right? Please remember this is 5a divided by itself, which is going to give us 1, and you have to write the 1, right? He's a little placeholder there for your binomial. And then over on the right-hand side, it looks like our two terms have a negative 6 in common. So we're going to divide everybody by negative 6, which is going to leave us with, what do you know? A plus 1, smiley face, identical parentheses. So now the a plus 1 becomes the GCF, so we take it out, and then what's left after we take out that parenthesis is 5a minus 6. So those are our factors, which of course, as you know, we are not done yet because we're trying to solve. So we're going to take each factor and set it equal to 0. So a plus 1 equals 0, and 5a minus 6 equals 0. So, of course, this first one's nice and easy, just a little one-stepper, right? So we move the 1 to the other side by subtracting. So we're going to get a equals negative 1. The other guy's a two-stepper, right? We're going to have to add the 6 over first. And then we'll divide by 5 to get rid of the multiplier on the a. And that's going to give us 6/5. Okay, and you know what I'm going to do next. If you want to, 6/5 is a nice friendly decimal. It is 1.2, so I would take either answer. The question above had that 0.3 repeating, and we do not do repeating decimals in high school, right? Or mixed numbers. So if you get the repeating decimal or the never-ending decimal, then improper fractions is the only acceptable way to go, right? But this one I will take either way, okay? So I'm going to go to Desmos check. It's totally worth my 10 seconds of time to plug that in. I'm just going to type in the original guy, 30x squared minus 6x minus 36. I'm going to tap on these little guys, and what do you know? Negative 1 and 1.2. Yay! There we go. Now, I know what I did not do, and sorry, I just thought about this. Technically, when we were doing this in class, we were writing our solutions as ordered pairs, right? So if our solution is x equals negative 1, right, that means that our actual solution as an ordered pair was negative 1, 0. And then same thing here, right, 1.2 comma 0, right? So I'm fine with you just writing the x equals or a equals. If you want to convert it to an ordered pair, I'm great with that too. If you want to write it as a solution set, right, where you're like negative 1 comma 1.2, oops, curly bracket, right? So I'm going to be okay on the test with however you want to write your solutions. Again, my emphasis is not going to be necessarily on the solution, but the process on how you got that solution. Okay, so any way you want to write your answer is totally fine with me. All right, guys, that concludes topic number 2, solving by graphing and factoring. All right, I'll see you in a bit for 7.3.